What we're going to demonstrate and discuss here is we're going to look at some past paper questions based around fraction operations. Now we're going to look at a couple that come from the National 5 Maths exam, and then we're going to look at one that comes from the National 5 Applications of Maths exam. This topic is covered in both courses, and the questions may vary slightly in the format between the courses, but the course skills are always the same. So I'm going to show you a couple of these, we'll work them through, and then we'll be able to see how to approach these questions using the skills associated with BODMAS combined with fraction operations. So the first two, I'm going to look at paper 1 in the 2024 exam and paper 1 in the 2023 exam, question 1 for both. So pause and have a go, and then let's see how you get on. So these questions typically come up early on in the exam. They're quite a nice settler that gets us going and gets us in the flow of the Nat 5 paper so that we can see. Now the first one, evaluate 3 2/3, take away 1 1/4. So there's two ways to approach it. We can either write them both as improper fractions, or deal with the whole numbers separate, fraction parts separate, and then combine them together. What I'm going to do for this one is I'm going to illustrate that second method. Whole numbers together, fractions together, and then see what the entire thing says. So if I look at the whole number parts, I'll have 3 take away 1, which will give me 2. I'll then have my 2/3 take away 1/4. Now remember, we have to have them over a common denominator in order to be able to do this. Two methods for doing that. There were the kiss and the smile, or there was looking at the denominators and just cross multiplying the fractions. So what I'd say is fine, I'm going to multiply everything in this first fraction by 4, and I'm going to multiply everything in the second fraction by 3. They're the opposite denominators. What that'll then do is that'll give me 8/12 take away 3/12, i.e. it's going to unsimplify the fractions. Doing that calculation will give me 5/12. What I can then do is combine these two parts and say, fine, that equals 2 5/12. Now a question like this, in this manner, will typically be worth 2 marks. The first mark will be the recognition here at this point, where you have to put them over a common denominator, and then the second mark would come in from the final solution. Now whether you use kiss and the smile or not, that common denominator, recognising that is key. Even if you went up a bit further, so let's say I had 12 as my common denominator there, if somehow I went to 24, but I scaled the tops appropriately as well, and I realised I was doing it, I would still get the first mark. The key thing for it is the common denominator. The second question, evaluate 2 1/6 divided by 8/9, giving my answer in its simplest form. Now reading that last part implies that you might have to do some simplification at the end, so we have to keep our eyes out for that. But remember, for dividing fractions, first we have to turn mixed numbers into impropers, then we use the stick switch flip method, and then we work it through from there. So first thing I'm going to do is I'm going to make it into a mixed number, an improper fraction. That first one there will then become 13/6 divided by 8/9. I'm then going to use stick switch flip, so it'll become 13/6 times, in this case, 9/8. Now if I don't notice straight away I can simplify, I could do the multiplications. However, I could look at this and say, well, I can simplify and cross divide here by 3 to end up with that as my fraction. So I'll have 13/2 times 3/8. Might just make our calculation a bit easier if we notice that. Doing that then, I'll end up with 39/60. So there we go, that's it in its simplest format as an improper fraction. It's not asked for it as a mixed number, but if I did change it into a mixed number, what I'd end up with is I'd end up with 2 7/16. Now it's not necessary, even though it does say simplest form, the key for the simplest form is factorising out that 3 at this stage here and being able to get that, or the next step when it's the 39/60. That's the key for that one. So for this one again, typically 2 marks. The first one for getting to this stage and recognising that you've made it improper and you've turned it into a multiplication, and then the second one, your final solution here, but it must be simplified. It specifically states simplification in the question. You specifically have to have simplification in the final solution. So there's your answer for that one. A couple more from the mathematics paper. First one's Mathematics 2020, paper 1, question 1. And the second one's from the 2016 paper, paper 1, question 2. They're ever so slightly differently. The second one combines different operations. The first one's just a simple multiplication on its own. So pause and have a go, then we'll check it. So if we come and check these ones together, that first one's a multiplication. Great. That's probably the easiest of the 4 operations, in my opinion, to be able to do. But again, our first step has to be to make any mixed numbers improper fractions. You've got this here as a mixed number, so let's change it, and I'd end up with 3 over 8 times 12 over 7. Now again, that phrase, give your answer in its simplest form, has an implication that we may have to simplify. We can wait till the end to do that, or I could look at this and recognise, well, if I'm cross-simplifying, I could cancel out a factor of 4 for both of these and make it a 2 and a 3. Now, if I were to do that, that makes my calculation a lot easier there, and I'd end up with 9 over 14. I'd still get that ultimately as my final solution if I did my next step and then simplified. Like I said before though, it just makes your calculation easier if you can do it at that step. So again, 2 marks. First step for recognising with the multiplication that you turn it into an improper fraction, so here, and then the second mark, getting your solution, but making sure it's simplified. Now the second one here, the 2016 paper 1 question 2, combines different operations together. So there's an addition in there, but there's also a 3/4 outside the bracket. Now what we have to remember is that hidden here is a multiplication between the 3/4 and the bracket. So it's 3/4 times whatever happens in that bracket. Now there's a couple of ways you could approach it. You could, if you felt a bit fancy, expand the brackets as we've done when it comes to expanding a single bracket with a coefficient, and then do 2 separate operations. Or I could follow simple BODMAS. I could do what's in the bracket first, and then multiply my solution by 3/4. That would be the technique I would follow. So I'd start by saying what I'm going to do is I'm going to do 1/3 plus 2 over 7. And I'm going to follow my set for that one. So I'm going to multiply the first fraction by 7, second fraction by 3, well, I end up getting 7 over 21 plus 6 over 21. Common denominator, we end up getting that. Then add them together and it'll give me 13 over 21. Great, that's the first step. That's my bracket. I can't forget then that I've got to do 3/4 multiplying that. So I'd say fine, that implies my final solution is going to be given by doing the calculation 3/4 times 13 over 21. Now again, if you look at the question, that phrase, give your answer in its simplest form, has the implication of having to simplify. Well, if I look again, and I'm going to cross-simplify, I could take a factor of 3 out of both of those. And it just makes it very simple in terms of the numbers I've got to do. Because my top would be 1 times 13. Hope by now we'd all realise that 1 times 13 is 13. Then my denominator would be 4 7s, which is 28. So I get 13 over 28. Again, if I hadn't noticed the simplification at the earlier stage here, I could still get that final mark as long as I simplified. I just have to make sure I did it. Now, this one here would typically be worth 3 marks because of multiple operations in it. Your first mark would be our denominator here, same as what we do with any addition or subtraction. Second mark would be the solution here, and then your third mark would be knowing to do the multiplication and getting the solution from it, but making sure your solution is simplified. You wouldn't get that final mark if your final solution wasn't simplified. Now typically in the maths paper, these come up as fairly straightforward questions like that. Here's an operation, here's a pair of fractions, or in the case of the 2026 paper, here's 3 fractions, do something with them. In the applications of maths paper, fraction operations do come up, but they're more contextualized. They'll take the fractions and they'll give you a context with them, and typically they'll get you to do something with it. If we look at this example from the 2025 paper, it was paper 1, question 1. One thing to note is that you'll notice all of these are paper 1, so they're non-calculators. So this is definitely a very big non-calculator skill, so bear that in mind whenever you're doing it. You'll notice that it's in a context of electing a head prefect. Now typically in the applications of maths paper, if you look back at fraction operations questions, what you'll find is it'll say, here's 3 parts of it, each worth a fraction. I want this part that's missing. So what you'll have to do is combine the fractions that you've got and then somehow figure out the gap that's missing that makes it up to a whole. Well, in this case, what we've got to do is we want to find the fraction of votes that Alison received. Now, there's 3 candidates, Fraser, Gracie and Alison. We have to figure it out from there. So what I'm going to do is I'm going to let you have a look at that and have a crack. Then we'll talk about it. So hopefully you've had a crack and a look. Now what I've got to remember is exactly what I said a moment ago. The key thing I want to do here is add what I know and then figure out the gap from there to get a whole. So in order to do that, I know that all 3 of them have to be added together to give me a whole, which is 1. So I can start by saying, well, my first step here then is having to do 3/8 plus a fifth. And I would just follow my same set of steps. Just because it's an applications and maths paper doesn't change the technique that we use. It just means that it's in a context. So 3/8 plus 1/5. Multiply the first fraction by 5, second by 8. What I'll end up getting is 15/40 plus 8/40. And I can then just use my standard set of steps to add them together and get 23/40. So that's Fraser and Gracie's total amount. I have to find what fraction's left for Alison. Well, I know all those fractions together should be 1 whole. So that means then that I know that Alison is going to be given by 1 take away that 23/40. So 1 could be thought of as 40/40. And it's then going to be take away the 23/40. So that's then going to give me 17/40. So that is going to be the fraction that Alison gets. Now the question doesn't go any further and ask you, for example, who's then won the vote. It wants that fraction that's left. That's what the question's asking you for. That's me got the solution for it, and that's me showing how to do it. So for this one, 3 marker of this question would be, first one is known here, your common denominator for the addition, which is the 40, or again you could do a multiple thereof, but 40 would be the easiest. Second one is known to add them and getting your solution is 23/40. Third mark, known to subtract it from 1, and you get your 17/40 as your final solution. So there you go, there's the approaches and examples from both the maths and the applications of maths paper as to how these questions typically come up. Bear these in mind. Same set of steps every single time, it's just for apps, it's a bit more contextualized. Now remember these skills and remember how we approach this. Always bear in mind, think smart, solve fast.